The geologic column. Does it show evolution? Evolutionists make some very bold claims. They say that the idea that life has evolved is as much a descriptive fact about nature as the fact that the sky is blue. They compare it to the theory of gravitation and declare evolution to be a fact. If all living organisms did evolve from a single-celled common ancestor over millions of years, how would we know? Where would we find the evidence? In the geologic column, which we have been studying. As you have already learned, there is a predictable order in the fossil record. That is what allowed William Smith to predict what fossils would be found in the next rock layers he was excavating. And this order was confirmed by Roderick Murchison and others to exist all over the world. This order in the fossil record is real. It is based on observable data. There really is a sequence that includes invertebrates, fish, amphibians, reptiles, and mammals. But is this really evidence for the evolution of all living organisms from a single-celled common ancestor? There's actually quite a bit of evidence in the geologic column that is not consistent with what we would expect to find if macroevolution is true. We will examine 4 predictions of evolution and compare them with the data. To understand the first one, we need a quick review of the way living things are classified. Scientists classify living organisms into several different categories based on common characteristics. Domain is the broadest category. Living things are currently classified by taxonomists into 3 domains. The next classification level is kingdom. Within the 3 domains, living things are classified into one of 6 different kingdoms. The most well-known kingdoms are plants and animals. We'll focus on animals as we continue our explanation. Living things in the animal kingdom are sorted next into various phyla based on the shape of their bodies. There are over 30 different body plans in the animal kingdom. If all living organisms evolved from a single-celled common ancestor over millions of years, we would expect that the fossil record should show organisms with new body plans appearing gradually throughout the fossil record. But that is not what we see in the fossil record. Instead, the data shows the abrupt appearance of fossils from most known animal phyla right at the beginning of the Phanerozoic layers, all with no apparent ancestors. This includes the same body plans visible in nature today, as well as some that have gone extinct. Because this abrupt appearance of body plans happens in the Cambrian system, it is called the Cambrian explosion. Charles Darwin was aware of the Cambrian explosion and how seriously it challenged his theory of evolution. He expected that as more fossils were discovered, evidence for the gradual development of body plans would be discovered, but it hasn't. Next, evolution would predict a sequence of organisms in the fossil record going from simple to complex. In other words, we should find simple organisms at the bottom of the geologic column, and increasingly more complex ones the further up we go. For example, we might expect to find a layer of simple creatures, such as simple sponges, near the bottom. A little farther up, we might expect to find a layer with simple sponges, more complex sponges, and corals. Higher, we might find simple and complex sponges, simple and complex corals, and brachiopods, which are organisms that lived in a bivalve shell but were not clams. New creatures, as well as more complex creatures, continuing to appear in a simple to complex sequence like this would be consistent with evolution. But that is not what we find in the fossil record. Instead, paleontologists have found fossils of highly complex creatures in the lowest Phanerozoic layers. Trilobites, for example, which are found all throughout the Paleozoic layers, were as complex as modern crabs. They had a brain, gut, heart, and compound eyes, and appear to have had body processes as complex as those of modern arthropods. Paleontologists have also discovered fossil marine communities that are just as complex as the marine communities we find in the modern world today. This complexity is located not just in the upper layers, but throughout the geologic column. Another prediction of evolution is that we should find fossil remains of many transitional fossils. What is a transitional fossil? Some sort of in-between kind of creature. You may have heard this referred to as a missing link. Another term for it is morphological intermediate. Morphology refers to what a creature looks like, its structure or shape. Intermediate, of course, means something in between. Although evolution predicts that we should find many of these transitional fossils, we don't. And the few that scientists think they have found are at relatively low levels of the classification system. None exist between kingdoms. None exist between any of the 30-plus phyla. Scientists have suggested possibilities for a transitional fossil between reptiles and birds, but none have been found between jawless fish and fish with jaws, or between fish with skeletons made of cartilage and fish with skeletons made of bone. Scientists have suggested an intermediate form between artiodactyls, which are animals with hooves, and whales, but none have been found between the other orders like insectivores and bats. Although most animal families lack morphological intermediates, scientists suggest that transitional sequences exist in the horse family and the hominid family. Other explanations for these alleged transitions have also been suggested, however. Instead of numerous transitional fossils in the fossil record, we actually find the abrupt appearance of different animals, very little change, and their abrupt disappearance from the fossil record. We can illustrate it this way. The green bar at the bottom indicates approximately where in the geologic column a certain creature is first found. The purple bar indicates that creatures continue to occur, but without a lot of change. The red bar at the top indicates where a particular creature stops appearing in the fossil record. Here are some examples of this pattern. Many different kinds of trilobites appear and disappear in the Paleozoic layers. Dinosaurs appear in the Triassic system and remain the same until they disappear from the fossil record in the Cretaceous system. Mastodons appear and disappear abruptly in the Quaternary system with little or no change. We'll look at just one more piece of interesting data from the fossil record that is not consistent with evolution. Evolution predicts that we should find descendants above their ancestors in the fossil record. To understand what those words mean, let's look at these pictures. Here we have a daughter, her father, and his mother or her grandmother. Relatives in a direct line like that can be called ancestors or descendants. Ancestors are relatives who lived before, like parents, grandparents, or great-grandparents. Descendants are relatives who lived later, like children or grandchildren. In other words, ancestors come first and then descendants. Or if we wanted to illustrate the idea vertically, like the geologic column, ancestors would be below descendants. Like this. In terms of evolution, we should always find ancestors lower in the fossil record than their descendants, because ancestors are older and descendants are younger, but that is not always what the fossil record shows. For example, evolutionists claim that dinosaurs evolved into birds. Let's compare the sequence of ancestors and descendants predicted by evolution with the actual sequence we find in the fossil record. According to the claims of evolution, we would expect to find dromaeosaurs, dinosaurs thought to be the ancestors of modern birds, in the fossil record, followed by feathered dinosaurs, Archaeopteryx or some other transitional fossil, and finally modern birds. Instead, we find dinosaurs, and then some rather strange birds that are very different from modern birds. Next, we find modern birds mixed in with these strange birds, followed by feathered dinosaurs, and finally dromaeosaurs. In other words, instead of finding these supposed ancestors of modern birds below the birds, they actually appear after or later in the fossil record than the birds themselves. Look at it this way. If the dromaeosaur is supposed to have been the ancestor of modern birds, we would expect to find it below the birds in the fossil record, but instead we find it after birds are found all over the world. That is like saying that Grandma was born long after her granddaughter. Let's summarize the 4 things we've discussed that are not consistent with evolution. Number 1, instead of new body plans appearing gradually, we have the Cambrian explosion, where most body plans are already present in the Cambrian system. Number 2, instead of gradually increasing complexity, we find both individual creatures and communities throughout the geologic column that are as complex as creatures and communities that exist today. Number 3, instead of numerous transitional fossils, we see a pattern of abrupt appearance, stasis, and disappearance. And instead of ancestors always appearing below their descendants in the fossil record, sometimes we find them in the wrong order instead. These data are inconsistent with what we would expect to find if evolution were true. As we continue this series, we will explore another option that is consistent with the data. Presentation 9 compares conventional geology with short-age geology, an approach which considers a broader range of possible explanations for the data. Presentation 10 describes biome succession, a hypothesis for explaining the geologic column in a way that is consistent with both science and scripture.